sample problems tayo. Yung gagamitin ko ng sample problems is from the activity. So, for problem 1, papakita ko na lang yung sa activity, no? So, wala akong ibang alam na examples eh. Actually, pwede natin balikan yun sa Fluma. Kasi lesson na natin sa Fluma to eh. So, dito sa problem number 1, alam nyo na yung style ko. Lagi kong sinusulat given, required, tapos solution. So, in a hydroelectric power, the tail water level fixes 480 meters. The net head is 27 meters and head loss 4% of the gross head. What is the headwater elevation? Bale, ganito yun yan. Sabi, may tailwater tayo. So, HTW is equal to 480 meters. Net head natin, so letter H, is 27 meters. Head loss natin, di ba? Sabi ko kanina, yung head loss, HF, given siya as 4% of the gross head. Yung 4%, divide natin ng 100, it is 0.04 Hg. Ganyan yan siya. What is the headwater elevation required? Ang pinapahanap sa atin is HHW. Solution. So for the solution, ano yung magagamit natin na formulas para makuha yung headwater? Diba, alam natin na yung gross head is equal to HW minus HTW. So to get, anong HW? HHW yan. HHW. Bali, pwede nating i-transpose to. And we get HHW, headwater, is equal to gross head plus the head tailwater. So, ito yung formula natin para makuha yung headwater. Pero tignan natin yung given. May given na HTW. Ito. Kaso, yung HG, wala. Wala pa tayong HG. So, kailangan natin hanapin yung HG. May given naman sa atin na net head at saka friction head. Alam natin na friction head na yung net head is equal to Hg minus Hf. Diba? Yung Hf naman natin is equal to 0.04 of the Hg. So, substitute natin. Hg minus 0.04 Hg. Makukuha natin dito, kumbaga, di ba, may 1 na coefficient dito. 1 Hg minus 0.04 Hg. Makukuha natin 0.96 Hg. Net head is equal to 0.96 Hg. So, we need Hg dito. Ayan. So, divide both sides ng 0.96 para ma-isolate si Hg. 0.96. Alam natin ngayon na yung Hg is equal to net head over 0.96. Ayan. So, kunin muna natin yung Hg and then input natin siya dito sa formula to get the headwater. Okay? So, kunin natin. Hg is equal to H. Ano yung H natin? Yung H natin is 27 meters over 0.96. So 27 divided by 0.96 is 28.13 meters. So ayan tayo. 28.13 meters yung Hg natin. So malapit na natin makuha yung headwater. Kunin natin yung headwater using headwater is equal to Hg plus HTW. Hg natin 28.13 plus meters to. Yung tailwater natin is 480 meters. Then we get headwater natin is 508.13 meters. Ayan na yung ating headwater. Ayan. So, next. Problem 2. Yung given natin, the available flow of water is 25 cubic meters per second at 30 meter elevation. So, Q, 25 cubic meter per second. Elevation, letter Z. Ay, hindi. Itong elevation, letter Z, sige. 30 meters. If the hydroelectric power plant is to be installed with turbine efficiency of 85%, turbine efficiency E sub T. Ako kino-convert ko agad sila into decimal points. So 0.85. Tapos yung generator efficiency natin, Egen is equal to 0.9. What maximum power that the plant would generate? Maximum power that the plant could generate. So, kapag sinabi ganun, maximum power that the plant could generate, yung power na tinutukoy nila dito is yung pinaka-output ng power plant, which is manggagaling sa generator. So, PGen. PGen yung hinahanap natin dito. For the solution, so ganito yung gagawin muna natin. Mag-umpisa tayo sa PW, PT, and hanggang sa makuha natin yung Egen, ay PGen. Itong Z natin, yung elevation, since wala naman ibang given dito na head or other elevation, ito yung ating net head. Yung elevation natin, siya yung net head natin dito. Okay? Ayan. Next, let's get the water power. Water power is Q omega H. Yung Q natin, 25 cubic meters per second. Yung ating specific weight is 9.81 kilonewton per cubic meter multiplied by head, which is 30 meters. So, if we use our calculator, makuha natin dito is 7,357.5 kilowatts. So, paano natin nakuha yung kilowatts na to? ganito. By units natin, cubic meter per second multiplied by kilonewton over cubic meter multiplied by meter. Itong cubic meter na to at cubic meter na to makancel. So matitira sa atin is kilonewton multiplied by meter over second. And kilonewton times meter is kilojoule. Kilojoule per second is kilowatts. Kaya nakuha natin yung kilowatts. Okay? So next. After getting the water power, pwede na natin makuha yung turbine power kasi may binigay na efficiency. Kung pupuntahan natin yung turbine efficiency formula, ET is equal to PT over PW. So cross-multiply lang natin to isolate PT. Multiply both sides by PW. PT natin ngayon is equal to ET times PW. Yan. So, 0.8685. 85 times 7,357.5 kilowatts. Makuha natin dito for turbine power is 6,253.88 kilowatts. Ayan. So this is our turbine power. Next, for the PGen, alam natin na may generator efficiency tayo na 0.9. So PGen is equal to PGen over PT. Cross multiply again. PGen natin ngayon is equal to PGen times PT. Ayan. Bali, 0.9 multiply by PT natin ito. 253.88 kilowatts. Ang ating PGen 5,628.49 kilowatts. Ayan yung PGen natin ngayon. Kung mapapansin nyo, pababa ng pababa yung power natin. Diba, nag-upisa tayo sa 7,000, naging 6,000, naging 5,000. So, may mga losses kasi, di ba? Hindi naman natin 100% mako-convert lahat. Yung input, hindi lahat siya mapupunta sa output. May mga losses pa rin tayo. Kaya binibigyan tayo ng mga efficiency na ganito. So, tandaan, PW, siya yung pinakamataas. And then, susunod yung turbine power. And then, yung pinakakonting power dapat is from the generator. So, for example, kapag biglang yung PGen natin mas malaki pa sa water power, double check nyo yun. Baka may mali sa computation. Okay? Next, number 3, sige. In a hydroelectric power plant, the brake power is 1,800 kilowatts. Brake power o kaya turbine power, 1,800 kilowatts running at 450 RPM. Yun yung speed niya. And net head of 30 meters. Determine the specific speed of the turbine in English units. So, ang tawag dito? NS, yung specific speed. Solution. Actually, dito sa problem na to, pwedeng diretso mo na siya i-ano sa SI unit eh. Kasi naka kilowatt at saka naka meters tayo. Pero since sinabi dito English unit, so mag-convert muna tayo. So NS is equal to N multiplied by square root of PT over H5 divided by 4. Ito yung formula gamit yung English units sa specific speed. So yung N natin, 450 RPM, wala magbabago dyan. Dito sa 1,800 kilowatts, alam natin na dapat naka-horsepower tayo kung English unit. So, convert natin, 1 horsepower is equal to 0.746 kilowatts. Ayan. So, cancel kilowatts, horsepower yung bagong unit. Yung namang head natin, so 30 meters, convert natin into feet. So, alam natin na 1 meter is equal to 3.28 feet raised to 5 divided by 4. Ayan. So, pakukuha natin sagot dito is NS is equal to 71.32. Unit niya, RPM. Okay. So, pakita ko yung sinasabi kong hindi na natin kailangan gamitin yung English unit. Pwede na natin gamitin yung tawag dito, SI unit na formula kung hindi nakaspecify dito sa problem. Dito sa problem nakaspecify na English unit yung gamitin. So, yun yung formula gamitin natin. Kung hindi naman nakaspecify, NS is equal to 0.2623 N muna pala, square root of PT over H raised to 5 over 4. So, 0.2623. Substitute natin yung N, 450 RPM multiplied by 1,800 kilowatts.
0.2623
Ay,
ba yun, Pres? O 26 pareho?
23 dapat. Ayan. Yung head natin, 30 meters raised to 5 over 4. So, makuha nating specific speed dito gamit yung SI unit is 71.33 RPM. So, almost the same sila. Almost the same. Ayan. So, next, sa problem number 4. A hydroelectric plant discharges water at a rate of 0.8 cubic meters per second and enters the turbine at 0.4 meter per second. Meter per second, so velocity. With a pressure of 280 kPa. Runner inside diameter is zero point 0.6 diameter, so zero point 0.6 meters. Speed N is 510 RPM. Turbine efficiency ET is equal to 0.86. Find the turbine speed factor. Sandali lang. Okay. So, excuse me. So, for the required natin, speed factor. So, yung 5. Solution. So, for the turbine speed factor or peripheral coefficient, phi is equal to pi dn over square root of 2gh. Yan. So, dito, meron na tayong D, meron na tayong N. Problema natin, wala tayong H. So, yung H, may formula tayo para kay H. Sabi naman dito, meron tayong pressure at saka meron tayong velocity. So, pwede natin gamitin yung head ng impulse turbine, which is ganito. Diba? Ito yung pressure, ito yung velocity. So, pressure natin is 280 kPa over yung ating specific weight ng water, 9.81 kilonewton per cubic meter, plus yung velocity squared, meron tayong 0.4 meter per second squared, over 2 times 9.81 meter per second squared. Ayan. So, makukuha nating head para dito is 28.55 meters. Paano siya naging meters? Ganito. kPa, which is kilonewton per square meter, divided by cubic meter, ay kilonewton 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 per cubic meter, plus meter squared per second squared over meter per second squared. So, magiging sa rules of division of fractions, yung denominator, multiply natin siya as reciprocal sa numerator. So, cubic meter per kilonewton plus to square meter square per square seconds multiplied by square seconds meter. Cancel ito, cancel. yung dalawa, cancel yung kilonewton, cancel kilonewton, cancel second squared, cancel second squared, cancel yung squared dito, cancel yung m. Matitira m plus m, which is m lang sa huli, yung unit. Okay? Excuse me again. Saan tayo? Problem 4. Okay. Next. Ito problem 5. Skip ko na kasi water power lang ulit siya. Ang problem. Ah, dalawang problem na lang, tapos pwede na tayo magkano. Umulit na lang yung topics eh. Next problem, ano naman tayo? Total, may notes na rin si Ma'am na binigay eh. Problem 5, skip ko na. Problem 6 na tayo. For generator running at 300 RPM. So, 300 RPM tayo. Mayroon tayo 60 Hertz, which is frequency. And then, number of generator poles, pinapahanap. Find the number of generator poles. So, required P. Solution natin, ganito lang. N, yung generator speed natin is 120 F over P. Diba? And pinapahanap lang yung P. So, mag-cross multiply lang tayo. Yung P, iaangat natin. Yung N, ibababa natin. So, P is equal to 120 F over N. Which is equal to 120 F natin, 60 Hertz over 300 RPM. Diretso na natin i-calculator. Makuha natin dito is 24. 24 volts. Wala tayong unit dito. Ginamit ko lang yung 24 volts para ma-indicate na poles yung P. Wala tayong unit dito kasi itong 1/2 na to, 'di ba sabi ko kanina, yung 120 na to may 60. So, 60 seconds per minute over R rev per minute. Ma-cancel yung minute and yung revolution, hindi siya lilitaw dito sa poles. Bale, no unit. Ginagamit ko lang tong pole para ma-indicate yung P na pole siya. So, next. Itong 7, skip ko na rin. Francis turbine lang siya. Same lang siya dito niyan. Same lang siya dito. Yung magbabago lang, magkakaroon ng plus elevation dun sa number 7. So, after that, na lang na tayo. Problem 8. So, problem 8 natin, a Pelton turbine has a gross head of 30 meters, Hg, 30 meters, friction loss of 4.5 Hf. The coefficient of friction head loss is yung F na to, coefficient of friction. So, 0.000, tatlong 0, tapos 93. Penstock length is 80 meters. What is the penstock diameter? So, sabi niya dito, friction head loss from Morse. Requirement natin, diameter. For the solution, alam natin na yung HF ni Morse is equal to 2 uh, FLV squared over, wait lang, ayan. Excuse me. Over GD. Ah, so, ngayon, we need to get the diameter, which is D. Meron na tayo, meron na tayong HF, meron na tayong coefficient of friction, meron na tayong length. Yung G, acceleration due to gravity lang yan. Yung kulang lang natin is the velocity. So, paano natin makukuha yung velocity? Ganito yan. Meron tayong given na gross at saka friction head. And alam natin, kapag nag-subtract tayo ng friction doon sa gross, makuha natin yung net head. Diba? So, 30 meters minus 4.5 meters, we get 25.5 meters. Yan yung head natin. Ngayon, yung head natin, dito sa Pelton, walang binigay na pressure and wala naman binigay na pressure. And alam natin na may formula tayo na nito, di ba? Yan. May formula tayo ganito for Pelton head. Kaso wala binigay na pressure. Okay lang. Ma-cancel out lang to. So our head for the Pelton turbine is V squared over 2G. So makukuha natin dito yung velocity nga natin. So gawin na lang natin dito is cross multiply. Yakit lang natin yung 2G. V squared is now equal to 2GH. Ako, hindi ko na kukunin yung V mismo. kunin na natin yung V squared kasi dito sa taas, V squared naman siya. Huwag na natin kunin yung square root. So, 2 times 9.81 meter per second squared multiplied by h is 25.5 meters. Makuha natin dito sa V squared is 500.31 meters squared per second squared. Bakit siya meter squared per second squared? Alam natin na meter over second squared times m. Walang natin dito, meter squared over second squared. Ganun lang. So, input na natin itong v squared dito sa Morse equation. So, write ko yun sa Morse. HF is equal to 2 2FL v squared over 2GD. Diba? Ay, ano 2GD? GD lang. GD lang to. And then, hinahanap is diameter. So, cross-multiply natin. Ibababa itong HF, akyat si D. D is equal to 2FL V squared over GHF. 2, yung F natin, 0.00093. Yung length natin is 80 meters. V squared. Meron tayong 500.31 meters squared per second squared. Acceleration due to gravity, 9.81 meter per second squared multiplied by HF. Yung HF natin, ano kasi siya? Friction head loss of 4.5 meters. For our diameter, we get 1.69 meters. So, I think doon na tayo mag-stop. Itong problem 5, ano to? Yung mga hindi natin na-review. 5, 7, at 9, 10. Ano lang, ulit-ulit na lang yan eh. Yung mga efficiencies. Kayo na lang yung mag-review dyan na. So, doon na tayo mag-stop para sa review na to. Post ko na lang sa YouTube yan.